Okay, thank you, Rico. And so I'm Joseph from the Chair of Geoinformatics, and in this project we are supporting CAT in T4, and we are working on several topics. And the topic that I'm working on is on sensor data integration in urban digital twins. And today I'm going to present our ongoing work on managing sensor data in urban digital twins metadata catalogs. As you all know, to create UDTs, you need 3D models to represent the physical environment. And then on the other hand, you need sensor data for real-time monitoring and also for trend analysis. And this sensor data comes from different domains, like the energy domain, mobility, and also environmental monitoring and so forth. And with this, you can basically monitor your city either in real time, or you could also do some trend analysis. But there are some challenges when it comes to integrating sensor data into urban digital twins. I think we have the same problem as the other slides there. So one of the issues that we encounter when we try to bring this data into urban digital twins is that different owners in the city may have this data, but they don't have effective data sharing strategies. And this makes it difficult for users who want to create urban digital twins applications on finding this sensor data. And another challenge is that we have a huge volume of IoT devices and sensors in the city. For instance, if we take the good example here of Hamburg city, in their IoT platform, they have more than 2,500 sensors. And this, if you're a user who wants to create a UDT application and you need some particular set of data, you may find it difficult you may not know whether this data exists, or even if it exists, you may not be aware of this. And one of the solutions to helping users discover the data sets that they need to create urban digital twins applications is urban metadata catalogs. And these basically provide data on which data sets are available, which tools and applications are there for users to create these applications. And from our chair, we have the SDDI, or the Smart District Data Infrastructure Framework, which has two main components. And the first component is a catalog, SDDI catalog. And this basically enables you to register all the data sets and tools that you have to help you create urban digital application. And this, you could also register your IoT devices, IoT services, to help users know that you have this data in the city and you can use this data to for your own tools. And the second component is the virtual district model, which provides a detailed representation of city objects. And this includes city building models and also transport infrastructure, vegetation, and so forth. But when it comes to adding the sensor data into this metadata catalogs, we have two ways we can do this. First of all, we can register the online services. So if you have an online platform like OGC Sensor Links API or Fireware in the city, which you use to manage your sensor data, you can register this in the catalog as an online service. And the second way is that you can register individual devices or a group of devices at the device items in these categories that are provided by this SDDI metadata schema. But we have several issues when it comes to also registering this data in the metadata catalog. One, due to the vast number of these IoT devices, it's very tedious and also time consuming to register all these data sets in a metadata catalog. And also at the current, we have two ways we can do the registration. As I mentioned before, you can either do a single entry of a sensor service. So for instance, in Hamburg, you could say we have the IoT Hamburg.de. But this, then you don't have sufficient information on what kind of sensor data you have in this sensor platform. The other option would be to register each individual sensor or device in the catalog, but this is not tenable if you imagine a scenario where you have thousands of sensors. Otherwise, when users come to your metadata catalog and try to look for data, they'll be overwhelmed by these search results. So in our work or research, we have a goal to enhance the discoverability of sensor data in these metadata catalogs. And how do we plan to do this? First of all, is to develop classification framework where we group IoT sensors based on their shared properties or similarities. And using these groups, then we enrich these derived categories with semantic information and use this to create metadata entries in the catalogs. And since we know that for these sensor data platforms, they are continuously evolving, users continue adding new devices, we need to make sure that these devices are also reflected or added also into this catalog. So one approach that we have is using standardized data models to try and group these sensors, like the Sensor Links API, where we do group all the devices that share the same sensors or devices that share the same observed properties. So we could say, for instance, all devices that have an inductive loop detector or all devices that measure temperature. We group them and we use these groupings to create metadata entries. However, so we've tested this, for instance, with a Sensor Links API instance we're using in the project, where we have more than 1,300 IoT devices in Munich, and try to use this standard model to create fewer groups that are easier for users to find. And we derived 18 categories based on their sensor type and also their observed properties. And we basically register this in this catalog. But this method relies on having accurate data in your sensor data platforms. So for instance, when you're adding devices to your sensor things platform or fireware, you have to be very consistent and very accurate for this approach to work, where you can group things that are IoT devices that are similar. So since this is not the way users create devices in sensor data platforms, they are not consistent, we are working on another approach where we have, currently we have a master's thesis students who are working on another approach using LLMs. And basically what he does is he has a registration pipeline. So first of all, you harvest your data from IoT services. This could be different IoT platforms. And using the harvested data, then you group this data based on, and you can classify this data using different tools. You can use heuristic grouping, like shared properties, like the sensor or measured property. Or you could also use LLM agents, or you could also train your own classifiers to derive better groups from this unstructured data. And then next step is to create metadata. So this metadata builder process, or the step, involves enriching these groups with information that makes them descriptive enough such that when you create metadata catalog entries, they are easy for users to find. So you want, if you create a group of sensors, users will be able to find either by searching using general names, or if they're looking for mobility data, they could search for mobility, they could search for public transport, and we need to generate these, and this is where we want to use LLMs to generate this kind of descriptive information for adding the devices. The next step is having a cataloger here, which basically then creates these metadata catalog entries. And this process is, we're creating it to be agnostic, so it's not dependent on one catalog. You could use this, for instance, in our SDDI catalog, or you have other catalogs like Metaverse, so we want to have this process able to be adaptable to any catalog or sensor service that you have. And this is just some of the preliminary results that we have from the IoT Hamburg dataset. So for instance, we fetch data from the sensors or the devices that you have in this platform. And one of the entries that we create in our catalog is an online service, which references to basically the server. And from this server, then we create a group of sensors, like which sensors measure public transport data in Hamburg. And we basically create them as a single entry instead of having to enter each device. So this ensures that, one, we have a reference to the online service, and then we have more details without overloading our catalog with individual entries, but grouped entries that are easier and also make sense for users to find, to discover. So in conclusion, we could say that efficient registration of IoT sensors in the metadata is crucial, because this means that users can find data that they need to create their UDT applications which otherwise would not be findable because, as we all know, in all these vast volumes of data or IoT sensors, some users might not be aware even about these data sets. And also we have to consider how users search for data in the metadata catalogs. Take for instance, if one user is looking for traffic data, they might use broad categories or broad search terms such as traffic data, or they might be more specific like traffic flow or search this data using induction loop detectors, radar cameras. So we have to understand how users also search for this information. And another important thing is that open data standards like OGC Sensor Things API provide data models that could be leveraged to create this categorization or classification of IoT sensors. And this helps us to create meaningful groups that are easier to find. And finally, we going to utilize LLMs to try and create more descriptive metadata entries and help in creating catalog entries from this unstructured data, which is created from different, by different users in their own different ways. So thank you for listening, and I hope I'm in time.